Hello again, everybody. I'm going to try and keep this video short and sweet. We are going to do some drawing and naming of alkanes, the simplest of all the functional groups. Alright? And if you guys can get a grip on how to name these guys, these rules that we're going to follow will provide the basis for pretty much all the other functional groups that you're going to see during the semester. So get these guys down now. It'll get easier for you later on. Alright? So how do we name compounds like this? Well, there's a set of rules that basically we have to follow. And we're going to start with how to name them. So if you're given a structure, how do you name it? Alright? Well, simply put, there is a correlation between the number of carbons in your carbon chain and the name of the alkane. Alright? It's basically like a code that you want to be able to follow, and basically it starts off like this. If you have one carbon, you have a compound called methane. I'm sure you guys have heard of that before. 2 carbons, your compound is called ethane. I know you guys have heard of that before. 3 carbons, you have something called propane. Some of you will have houses that are heated by propane. 4 carbons, you have butane. Those of you that smoke those cigarettes will use butane in your cigarette lighters. And it carries on. 5 carbons is pentane, and then 6 carbons is hexane, 7 carbons is heptane, then octane, nonane. Your book has that list. So that's one thing that you need to make sure that you can get straight in your head, because you need to know these names before you can go any further. So for example, if I was to ask you to name this compound, well, the only thing you have to do is count up, well, how many carbons do I have? 1, 2, 3, 4. So I have 4 carbons. That is butane. It's not butane. I suppose you could call that if you wanted to. It's butane. If I drew something that had 5 carbons in it, it'd be called pentane. 6 carbons, hexane, and so on. The part about naming these that makes it more complicated is when you don't just have hydrogens coming off the carbons. What if we had something like this? What if I was to do this? Alright. So this is what we have. And if I was to put all the hydrogens on here, you'd have to figure out, well, how do I name that? So the first thing that you need to do is to look for the longest carbon chain. Alright? What's the longest carbon chain that you can count carbons in, alright, without stopping? In this case, that is 1, 2, 3, 4. Alright? I chose red for that just to show you that I can also count 1, 2, 3, 4. In that case, it doesn't really matter which side I count from in this case, whether it's red or green. My answer is going to be the same either way. Now, that's not always going to be the case, and we'll talk about an example where it's not on the next page here. But if you can figure out what the longest carbon chain is, that's the first thing that you want to be able to do. So the longest carbon chain here, no matter how you do it, is clearly 4 carbons. So that means the parent chain, we're going to call it, is butane. The parent chain is the longest carbon chain in the molecule. Alright. Once you've got that, then you have to figure out, well, what's left? What haven't I numbered yet? Alright. If we go with the green colors here, so I'm just going to scrub out the red ones. These are our 4 carbons, carbons 1, 2, 3, 4, but we haven't taken into account this one. And we have to, otherwise our name isn't going to be correct for a structure. Can you guys see that this group, whatever it is coming off carbon number 2? So that means in our name somewhere we're going to have to represent the fact that something is coming off carbon number 2. This guy is what we call a substituent. It's called a substituent because it's coming off the parent chain. Alright, it's coming off the parent chain on position number 2. Notice this substituent has 1 carbon in it. Alright, we said before that a 1 carbon chain is called methane. When we go from carbon chains to substituents, we change the name from methane to methyl, because methane is a carbon with 4 hydrogens around it. Notice how many hydrogens are coming off this carbon. There's only 3, because the other carbon is connected to the parent chain. Alright, a methyl group is what a CH3 group is. So just as methane makes methyl as a substituent, a 1-carbon substituent is called methyl. A 2-carbon substituent is based on ethane. That actually becomes ethyl. Propane becomes propyl, butane becomes butyl. You get the idea. So what we have here is a 1-carbon substituent coming off carbon 2. We've already said that the name of our substituent is methyl. Carbon 2 is where that methyl group is. And the way these names go, ultimately there are 3 parts to the name. Alright? The part that comes last is the parent chain. The part that comes first is the number locator for where the substituent is, and then this part is the actual substituent. So 2-methyl butane will be the name of this guy. And one other piece of bookkeeping here: anytime we have numbers and letters when we're naming these things, we always separate numbers and letters by a hyphen. Alright? Okay. Actually, you know what, let me just go back a little bit. Now, I want to show you one other way that we can actually draw alkanes out, because drawing things out like this takes a little bit of a while, and it gets to be kind of a pain in the butt when you're drawing all these carbons out. Wouldn't it be nice if there was a nice shorthand way to draw these out? And actually there is a shorthand way of drawing these out. This 4-carbon molecule can be shown just like that. I know this seems kind of weird, but carbon 1, 2, 3, 4, the same as carbons 1, 2, 3 and 4 here, are exactly the same as carbons 1, 2, 3 and 4 here. One thing you're going to see a lot of in this organic chemistry class is me drawing things like this, because it's a lot easier to do, but it does require a little bit of understanding about what this actually means. Okay, so just think about it in terms of lines. Alright, carbon number 1 here and carbon number 4, notice you can call these essentially the start of a line. Alright, because that's where the line starts. Anytime you have the start of a line, you have a CH3 group. Alright, we've got 1 here and 1 here. Anytime you have the intersection of 2 lines, notice for carbon 2 here you've got this line and this line intersecting. That means you've got a CH2. Alright? We have the same thing here. If you want to think about it this way, that if this is your carbon here, there are 2 other carbons bonded to it because there are 2 lines shown. If each line represents a carbon bond, carbon-carbon bond, then that tells you how many carbon bonds there are. And because you know that carbon likes to make 4 bonds, we've seen that already. If you show on carbon number 3 here the fact that there's only 2 bonds shown to it, that means there must be 2 other bonds to hydrogen that just aren't being shown. Like I said, this is a shorthand way of drawing this out. The hydrogens are there, they're just not being shown. Alright? It just saves a bit of time. So what about if we were to try and draw out this 2-methylbutane in exactly the same way? Alright? Well, butane, of course, is 4 carbons. That's our parent chain. But on carbon number 2, we have a methyl group coming off it, and a methyl group is 1 carbon. Alright? If we call this carbon number 2, we have 1 carbon group coming off that, which means we have to have the end of a line coming off here. Alright? So what that means is the end point of a line, like we said before, represents a CH3. And if you look at this structure, you've got a CH3 here, a CH3 here, and a CH3 here. Meaning, in this structure, there should be 3 CH3s, or 3 end points of the line. And actually there is. There's 1 here, 1 here, and 1 here. Also notice here there is a CH2, which is this guy right here. But what's this guy? If a CH3 is the end point of a line, the CH2 is the midpoint of 2 lines, what's the midpoint of 3 lines? Well, it's a carbon with 3 carbons bonded to it, and so only 1 hydrogen. That's this one here. So endpoint of a line is a CH3, midpoint of 2 lines is a CH2, midpoint of 3 lines is a CH, and if you could have this, a midpoint of 4 lines would be just a carbon, which you can have. Let's run through a couple of examples of these, okay? What if I was to ask you, can you name this guy? Alright. The first thing you've got to do, as we said before, is figure out the longest carbon chain. Alright. And in this case, that's going to be, you know what? Let me just make one difference to this. Alright. Let me add something here. I'm going to do this. Alright. The longest carbon chain is going to be carbon 1, 2, 3, 4, 5, and 6. Now notice I chose to number from the left here. What if we said this? Well, what if I want a number from the right instead? You know, screw your number from the left. I want to do it from the right. Which is right? Well, it actually varies per situation. What we're looking for here is which one of these is correct, because the fact is only one of these is correct. If you aren't sure about something like this, you always need to use the substituents to tell you which one is right. So notice, where are the substituents here? Well, the substituents are the pieces coming off the parent chain. If this is the parent chain, we've got a substituent here, we've got a substituent here, and we've got a substituent here. Alright? Notice how many carbons each substituent is. It's 1 carbon here, 1 carbon here, 1 carbon here. We saw before that a 1 carbon substituent is a methyl. So this means we got 3 methyls. Alright. Now, to figure out which side you count from, what you're looking for is you always want the lowest substituent numbers for your substituents. Alright. You want them to appear in the lowest possible place on the chain. Which means you want to start from the side where you see a substituent first. In other words, if we go from the right here, the first carbon we come to is carbon 3 with a substituent on it. 3 plus 4 plus 5. These are our substituent totals counting from the left. Actually, that's 12. 3 plus 4 plus 5. When we count from the right, our substituents are on carbons 2 and 3 and 4. 2 plus 3 plus 4 is 9, 3 plus 4 plus 5 is 12. You always want the lowest number possible. So therefore, that's why in this case we count from the right. So, now what do you guys remember? What's the name of a 6 carbon chain? Well, that is hexane. Alright. We have methyls. And for each substituent, we need a location number. So we can't just have one number. We need one number for each of our substituents. Alright. We have a substituent on carbon 2, and one on carbon 3, and one on carbon 4. And we've seen already that the name of a 1 carbon substituent is methyl. So I'm going to put that here. However, one of the issues that we have here is, well, first of all, this looks like 234 methyl hexane, which obviously can't be right. We always separate numbers in a name by using commas. Alright. We've seen before that we separate numbers and letters with a hyphen, so we are going to put a hyphen here. But we also need to let the reader know that we understand there's 3 of the same substituent. Alright, so we use these things called prefixes, alright, to indicate how many of something we have. Di means 2, tri means 3, tetra means 4, and so on. In this case, the prefix, of course, we're going to use is tri. 2, 3, 4, trimethyl hexane. Alright, the only place we use the hyphen is here because it's the only place we separate numbers and letters. We always use the commas here because we're separating numbers. Alright. Now, here we get down to one that's quite a bit more complicated. Alright. But we want to ask ourselves exactly the same question first off. What's our longest carbon chain? And if we ask ourselves that and then look at, well, which side are we going to start numbering from? Well, carbon 1, 2, 3. I've seen my first substituent here on carbon 3. 1, 2, 3, 4. My first substituent here is carbon 4, so that probably means I'm going to start from the left. So I'm going to do that. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Alright, now the name for a 9-carbon alkane is nonane or nonane, or however you want to pronounce it. But let's look at the substituents that we have coming off there. Alright, we have this guy and this guy. Now we've seen these before. These are 1-carbon substituents. These are methyl groups. It's not really a surprise. We've seen these before. And they're on carbons 3 and 4. But there's also this and this. Now how many carbons are in these substituents? Remember, we're only concerned about the carbons coming off the parent chain. We're not concerned about carbon 6 here. We're just concerned about these. There's 2 carbons here and 2 carbons here. These are 2-carbon substituents called ethyl groups. Alright? So we have to figure out how to put all this into the name. Because we've got methyl groups on carbons 3 and 4, ethyl groups on carbons 5 and 6. And there's a few things we have to remember. Remember, we need a number for each separate substituent. So how many numbers do we need here? Well, we've got 4 substituents. We need 4 numbers. Remember also, we need the prefix to tell us how many of each substituent we have. Well, we have 2 methyls. Di is the prefix for 2. So we know in our name we're going to have the prefix di for dimethyl for 2. I've got 2 ethyl groups as well, so for diethyl. But then the question comes, well, here I only have 1 substituent. Here I've got 2. Which one comes first in my name? Well, there is a rule for this. It's simply alphabetical. Alphabetical in terms of the name of the substituent. Di has nothing to do with the name of the substituent. It just tells you how many of each there are. E is the first letter for ethyl. M is the first letter for methyl, therefore E comes first. Alright? So therefore what that means is, in our name here we're going to have diethyl, and we're going to have dimethyl here. I'm leaving some room for the numbers because I know they're going to be coming in here. Alright? Now when you look at the ethyl groups are on carbons 5 and 6, so we're going to say 5, 6, and we use the hyphen to separate the numbers and letters. 5, 6 diethyl, and then the methyls are on carbons 3 and 4. Again, I use a hyphen to separate numbers and letters, commas to separate numbers. 5, 6 diethyl, 3, 4 dimethyl nonane. It doesn't matter that these numbers are higher than these. It's alphabetical ordering of the letter that comes first. All right. Now that's structures to names. What's easier is names to structures. All right. 2-ethyl, 3-methyl, hexane. Well, hexane, of course, is a 6-carbon chain. There's 6 carbons. All right. It doesn't matter which way you number. So let's say we number from the excuse me. You know what? I realized I balls this one up. Hang on, that one's a load of bollocks. I'm sorry. I didn't realize that one was wrong, but we can still do this one. 3,3-dimethyl pentane. So let's just start off with that. Pentane, 5 carbons. All right. 3,3-diethyl pentane. I'm sorry, I said dimethyl. 3,3-diethyl pentane. So we have to take from this that there are ethyl groups coming off pentane, and because it says di, it means there's 2 of them. You can also tell there's 2 of them because there's 2 numbers. But then we just have to ask ourselves, well, what does diethyl look like? What do ethyl groups look like? Well, those are 2-carbon groups. That's 2 carbons. That's 2 carbons. Alright? You don't have to draw it exactly like this, but that would tell you 1, 2, 3, 4, 5. That's my pentane parent chain, and then coming off it is 1 ethyl group, and coming off is the other ethyl group. Alright? Anyway, that's how you name and draw alkanes. It really isn't that difficult. All you guys need is practice, which we'll get in class. Alright, thank you.